In this video, we're going to look at how to prove congruent triangles using angle, angle side, and HL. So for the first example here, we have some givens and we look at what we're trying to prove. So we're trying to prove triangle PQS. So this triangle right here is congruent to triangle RQS. So this triangle on the other side. And I have some givens that we can go ahead and mark. And let's go ahead and get those in our proof. So we have QS is perpendicular to PR. That's given. And then PQ is congruent to RQ. So if I go to mark those, QS is perpendicular to PR. That would mean that there's going to be right angles, which you can see that those are already drawn in. But I need to state that I have right angles. So let's go ahead. I'm going to number those, not 1 and 2, because 1 and 2 are already being used. So 3 and 4. So I'm going to go ahead and say that angles 3 and angle 4 are right angles. So this would be found in your blue reasons in your bag. Because you're starting with perpendicular lines, so your conclusion is that you have right angles. So perpendicular lines imply right angles. So even though it was marked already as right angles, you do need to state it because your given was the perpendicular line. So when you mark perpendicular lines, you mark right angles, but you do have to still state it in your proof. And then it says PQ. So PQ is congruent to RQ. So from there, the only thing that I really could say is that I have an isosceles triangle and then angles opposite those sides are congruent. So you could go that way with it. But for this one, I'm really just going to leave this as, okay, I have two congruent segments. I'm going to leave that. And I'm going to go to my diagram and look. So you could do the whole isosceles triangle thing. But for the sake of this problem, I want to show you a different approach. So here, I'm just going to leave that. I'm going to look at my diagram. I see a shared side, so I'm going to go ahead and mark that. So that's my reflexive property. So QS is congruent to QS by reflexive property. So now when I look at this, I can identify which method. I see I have an angle, a side, and then another side that's not making this angle included. So it's not going to be side, angle, side. It would be angle, side, side, which you can't have because that method doesn't work. Side, side, angle, or angle, side, side, the donkey theorem. So instead, that indicates that we should be using HL because what that means is you have a right angle, you have the leg of the right triangle, and you have the hypotenuses. So this really means we're going to be using HL, and I always put dash right triangle because it only works in right triangles. It's the side-side angle case that works, but it has to be in a right triangle. So that means when I go to write this up, I have to make sure I've stated these three things. So when I look at my proof so far, my hypotenuse, so that's the PQ and the RQ, I stated that right here, so I can check that off. The leg means you stated a pair of congruent legs, which we have the reflexive property. And remember, I used the diagram to do that. So I've used all these given, so I really could check those off. And then the right triangle, I have right angles, but I never stated I have right triangles yet. So that's what I'm going to state. So instead of saying that angles 3 and 4 are congruent, that would be if I had like an A that I was trying to prove, a pair of congruent angles. In this case, you're trying to get a right triangle. So that means what I'm going to do is I'm going to take this, and from there I can say that these two triangles that are listed here, so PQS and RQS, are right triangles. This was one of our mini proofs, remember, that if you have right angles in a triangle, well, that means that that triangle is a right triangle. So each of these triangles both have one right angle. So a triangle with one right angle implies a right triangle. So given the fact that I had right angles, implies that those triangles must be right triangles. And remember, it does also imply that the right angles are congruent, but I don't care about that for the sake of HL. So HL, in order to make that last check, you have to state that there's right triangles. So now I've seen that there's right triangles, so I've checked off, I've done all of these things. So now I can bring all of these statements together here. So this, and this all come together. And now I can say that the two triangles are congruent by HL, and I'm going to just call it HL dash right triangle because I want to really highlight the fact that you always have to have that right triangle. That's your third piece of information. So that's a proof using HL. Let's look at one using angle side so you can see that. So here's my two triangles I'm trying to prove. So we can go ahead and highlight those. So we have PMK, and then I have triangle NMQ. So this triangle here. I have some information given to me. I'm going to go ahead and record that, label my diagram, and then look in the diagram. So M is midpoint of PN. So angle P is congruent to angle N, so you can go ahead and mark that. So for that, there are some conclusions you could make from that. You could say, if you looked in your yellow reason, since you have a pair of congruent angles, you could, in this situation, since I have a transversal, I could imply that these lines are parallel. And then once I have parallel lines, that means these other alternate interior angles are congruent. You can do that if we need to. That's a little bit longer of an approach. Kind of like in that last one where there were other ways that you could get more congruent angles or more congruent sides. It's not always the most efficient way. So let's just kind of leave that for right now. So that's the only conclusion really I can make from that. And again, I got that from looking at my yellow reasons because it's an angle given. So really for this one, I'm just going to say, okay, I've used that. I've marked it, and I'm just going to leave that. Then I look at the next one here. We have M is the midpoint of a segment. So in your segment reason, so that's the pink, you would find a midpoint implies two congruent segments. So when I look at PN, I'm going to just go ahead and highlight that. That's the segment that has the midpoint. So that's the segment that's getting split into the two equal parts. So from that given, the conclusion I can make is that PM is congruent to MN. So remember, you state your congruent segments, and then your reason is that slip of paper. So midpoint implies two congruent segments. So now I've used that given to make a conclusion. And now I always am going to add the diagram as something we're going to check. So check the diagram, and I see an X. So that means I'm going to write I have vertical angles. And I'm going to just number those 1 and 2. So I'm going to go ahead and say angle 1 is congruent to angle 2. So that's from the diagram. So that is vertical angles are congruent. So that's my reason for that. And then from here, I need to see, do I have enough information? So just by looking at the picture, I can see that I have two sets of angles and a side included, or the side that's between the two sets of angles are congruent to each other. So that would be angle, side, angle for both of these. So that means my theorem I'm going to use is angle, side, angle to prove that the triangles are congruent, which means that I'm going to look at this and make sure I have all of this stuff mentioned in my proof. So if I look, I have a set of angles, I have the side between them, and I have the other set of angles. So by angle, side, angle, I can say that my two triangles are congruent. So triangle PMR, I believe, or is that a K? I think it's a K. Is congruent to triangle NMQ. And that's by angle, side, angle. Now, if you remember at the beginning of this proof, I said, okay, we're going to use angle, angle, side for this. But then this was actually a shorter approach to just use angle, side, angle. If you wanted to use angle, angle, side, what you would have had to do is back when I was talking about these being alternate interior angles that are congruent, which would imply the parallel lines, you could have gotten that these lines are parallel, and then from there, that would have allowed you to mark that these angles are congruent since you had the parallel lines, because parallel lines imply congruent alternate interior angles. And then from there, I would have been able to use angle, angle, side, because then the purple and the green angles would have been two angles with the side not between them. Or you could have used the green and the pink as your two angles, angle, angle, side, and then not even talked about the vertical angles. So that's, again, kind of the beauty of these proofs, is that there's multiple ways of doing them. If I would have done angle, angle, side, it would have been longer because I would have had to bring in the parallel lines and continue with that. This, using the vertical angles, is definitely a direct approach to this, so it's a lot quicker. But either way is completely correct, and it's really just kind of what you see at the time that you're doing the proof. So just keep that in mind. So go ahead and try the check your understanding problems. And remember, there could be more than one method. Just because this is in the HL angle, angle, side section doesn't necessarily mean that that's what you're going to be using. So just keep that in mind. It's whatever you see, and as long as you're making valid conclusions, you're good to go with it. So go ahead and give those a try.